Hello, everyone, and thanks for attending my session in data science stream. Today, I would like to introduce to you a tool called KNIME, pronounced as KNIME, as in knowledge. KNIME has been in industry for several years, and I've been using since then. In this session, I'll be covering how to use the Neo4j components in KNIME. KNIME is really fun tool to use. My name is Dominic Kumar. I'm an enterprise data architect currently residing in London. A quick intro about me. I have around 20 years of experiences in data world. SQL Server 6.5 and Oracle 9a were my first databases, and I started to work with them. Along my career, I worked in all data-related roles from database developer to data architect and places from Ohio to Texas before settling down in London. I had domain knowledge of oil and gas and airlines transportation. Outside my work, my hobbies are learning to fly, music composition, and traveling. This is my first session for Neo4j conference. One of my success stories back in spring 2019, where I presented optimizing airline routes using Neo4j path finding algorithms. This led to three major transportation clients who attended the session, migrated from their existing legacy data store to Neo4j graph database, and were able to lower the operation cost and increase revenue. Apart from this presentation, I frequently visit Neo4j community forum and answer questions, and was 2 times feature member in Neo4j community. Before I proceed with the presentation, just a disclaimer. This presentation is not a sales or a promotion from KNIME. This is just a presentation of using KNIME, a free downloadable tool along with Neo4j components. And I just wanted to share my experience using KNIME to the community. Here's a brief agenda of today's session. Please free to post to questions in the Q&A section, and I'll be happy to answer at the end of the session. In a typical day, we download a data set, use Python, Jupyter Notebook to build machine learning algorithms and visualize the output. But this is not the case. In reality, the visualization looks like this. We spend more time cleansing the data than working on the machine learning. We call ourselves as a data scientist, but we clean so much of data and that we call ourselves as a data janitors than spending time on building the correct machine learning model for building and training models. I guess the pie chart tells the story by itself. In a typical machine learning project, there are 3 phases: explore, research and development, and productionization. Looking at these linear streams, anyone can conclude that this resembles a waterfall approach from software development cycle. But in reality, it's not a linear process. Each and every component has a dependency among itself, and the dependency factor increases as we progress from data capture to visualization and then to productionization. To add insult to injury, in an organization, the phases and the components are performed by various teams, such as data engineering, analytics, scientists, DevOps, DataOps, and also BI team. Even though we see a workflow connection between various teams, there is always still a siloed flow between the teams itself. By the time the data scientist needs a fresh data set or needs to add a missing data points, there are possibilities that the data engineers who are responsible to capture and load the data and the DevOps who implemented the CI/CD pipeline might have moved to a different project. This becomes a huge time and resource gap, and this becomes a very critical issue when trying to bring in business and build up revenue to the organization. Besides the silo teams I mentioned before, there are also duplicate effort within the each and every organization and each and every teams itself, which causes delay in time to market and also client buy-ins. So far we have seen data science creation. So apart from those gaps in between the teams and the organization, there's a invisible or thin gap between data science creation and also data science production. Data science production is not just coding in Python notebooks, but it takes more collaborative efforts from various team members that I mentioned in my previous slide. There are cases where huge amount of data are being dumped and the real value of the data still is unknown to the data scientists. And this is very invisible to because of the huge volume or veracity and the variety of the data. the data scientists still have to spend more time to analyze what valid points they need to analyze than to spend time on really very good valid data points. To minimize these gaps, KNIME offers a end-to-end orchestration for data science workflow. It also features Neo4j components to read and write data from and to Neo4j. So, what is KNIME Analytics Platform? It is a single workstation tool it's an end-to-end orchestration. It can build one end-to-end orchestration for data and tools integration. This single tool can perform data capture from various data sources, analyze them, wrangle claims, visualize, report, and also even deploy it to production as a CI/CD pipeline, similar to CI/CD pipeline. It also features a lot of big data components and cloud components. And among them, I have listed a few components which are most popularly and mostly used in many of the workflows in today's data analytics. It also has APIs for Twitter and Facebook for analytics. The atomic component unit of KNIME is called a node. A node has an input, output, and the execution status or the status indicator similar to the traffic lights are provided as a visual indicator to visualize, indicate what is the success, failures, whether it's been configured, not configured, executed successfully. So all these status are being visually represented within the node, below the node itself for each and every component. For example, here, as an example, as a column filter, say, for example, if you're having 5 columns and you want to filter only 2 columns, the execution state when it's not being configured will be in amber color, but once it's being executed, successfully executed, it will be green color, and of course, if it's here, it has an X mark. A typical time data pipeline workflow. So this is how a typical workflow looks like in a KNIME. The data is being captured using the rating nodes, and it's being deployed to for productionization using deploy nodes. A very good feature of KNIME that I really like the most is each and every component is colored, so you can quickly analyze or we can quickly see what are we doing in our own workflow than spending to open each and every component and checking whether they are reading some data sources or transforming or analyzing. This is an example of an end-to-end workflow from KNIME website that I downloaded for a presentation. As you can see how neatly the workflow can be arranged in a swimlines fashion. And because of the status indicator, like the traffic lights that I mentioned before, it can be easily to identify the failures during the debugging process. Don't be alarmed with all the components that are listed here. This is just an example. Maybe it depends upon each and every use cases for the workflow, how many components you're going to use. So KNIME offers 3 Neo4j components: connector, reader, and writer. From the component name itself, we can conclude the functionality. Reader and writer provides a cipher query window similar to Neo4j browser interface to query the Neo4j database. I'll be providing a simple demo on each and every component. As Linus once told, talk is cheap, show me the code. Let's quickly jump into the demo. Thank you. So I've already downloaded KNIME, and this is the very first startup screen. When you start up KNIME, you have a welcome page, and I really like this welcome page because every time I open this welcome page, there's always news, updates, blogs, tips and tricks that's really useful for data orchestration purpose, and also KNIME releases new components once in a while, and they're always very attractive for the data scientists to build the orchestration. Just to go before we go into the actual demo of the real data set, I just wanted to show how the Neo4j components interact with each other. So the Neo4j connection is just connects to the database. It has a URL, and we can provide username and password, and it connects to the Neo4j session. And the reader, it provides, as I mentioned before, it provides a cipher query window similar to the Cipher web browser. And one of the good feature about the reader node is, it also displays all the nodes, their properties in the single window itself. And apart from them, you also have uh, documentation that is already displayed for all the epoch procedures or the custom procedures that are inbuilt, or there are plugins from Neo4j. So this is a reader node. Just for the demo, I'm going to execute it, and you can see that the success of the execution is in green color, and you can see the nodes being displayed. And similar way, we have Neo4j writer, where we can write merge queries, create queries, either nodes, creating nodes or creating relationships. And it can be executed since it is being configured, it's not being run. We can run it and it can show us green color. And when we read the back data again, we can see that the data is being created. So coming back to one of the demo data set. So this is a typical workflow that has many components integrated for a end-to-end data science orchestration. In this example, I have taken podcast as one of the example. As you know, everyone is really familiar with podcast. For the sake of demo purpose, I have split the Apple's API podcast writing into 3 different files. Simulating a functionality saying that displaying that there are 3 different files. They are maybe coming from 3 different databases, 3 different tables, and we have to clean it, we have to remove it, we have to join into different data sets. So as you can see, I'm reading a podcast file here, and it automatically shows all the features, all the data for the first 1,000 rows. And another interesting feature of KNIME that I find it very interesting is, just for the demo purpose, what I've done is I have make sure I have many components, and these components can be grouped into one master component and named as data cleansing. So if you see that your entire workflow is also clutter free, and it's very neat to follow through the process of the orchestration, all of the lines. The blue lines represents the connection of the flow of the connection from left to right or along the arrow marks. So in this example, I'm combining the country, the podcast file. The podcast file has IDs, and the podcast ratings has the IDs, and also the number of ratings from each users based on 1 to 5 stars. In this process, I'm filtering what all the columns that I need using column filter. And another example is I'm joining 2 different data sets based on the IDs, and and also I'm performing a column cleansing for changing the entire column header um, of the data set. So we used to use before I was using Cipher query and writing individual Cipher queries to clean and going back to the real data source, making sure the data are being joined. But in a typical situation, not all the data that comes as a data are denormalized. Most of the data are normalized data when you work in an organization. All the data or most of the data have a master data file where there are only IDs, and we have to combine them, join to another table. When we have a denormalized data set, the problem is that the size of the data set is also huge, and processing it in Neo4j is also very huge. So instead of that, we can normalize the data, we can download as it is, and we can combine them in KNIME to create a very good data orchestration. After I cleansed all the data sets, I'm creating 2 main nodes, podcast node and genre nodes. And after the podcast and genre nodes are created, I'm creating relationship between podcast and genres and podcast and ratings. And after I've created all the relationship, I have built a visualization. So let me run this tool first, and I'll go back. I'll explain the how it is being. So all you have to do is that you have to click on the workflow and execute it. So like you can see from uh, the green color, the execution has finished. And just wanted to show how the nodes are being created. I made sure that have a very big data set so that I can show it. So I'm opening this podcast to ratings, and as you can see, that I have split that. If I provided this workflow in one single, there's I cannot show the I cannot give you a correct demo. So since I split out, you can see that each and every node has been created and it has gone through the process. Let me run it again because it has completed very quickly. Reset and execute again. So I'm going to go back to the podcast ratings, and you can see how fast it is able to capture. And if you can see, it is just moving very fast here. So it is capturing the podcast ID, and it is combining with the ratings of different rating, and it's trying to create a relationship. So in a typical, this is just to show how the nodes and relationship created, but there are a lot of ways. You can use epochs procedures to create more faster and more efficient loading of the data. So now the data is being loaded, and when we come to visualization, uh, there are there are so many visualization, but the most favorite is the Data Explorer. So the Data Explorer gives you the overview of all the data statistics, just like we used to have a Jupyter. We used to have EDA, explanatory data analysis. Similar to that, KNIME also has an inbuilt Data Explorer. So I can quickly analyze the minimum, maximum, mean, median, and standard deviation of data. And in addition to it, it also gives you the histogram of the distributions of number of ratings and number of screeners, zeros, number of missing values. Since I've already discarded the zeros and missing there, so there's no missing. But in maybe in a typical data set, there may be zeros and non values. Then we can refer it. And my second favorite among everything, all the chart is the sunburst chart. Sunburst chart gives you a quick overview of all the data and how they are related. For example, this sunburst chart gives you the relationship of a genre, podcast, and an artist, and it's also interactive. So all I need to do is just go near pick one of the genres, and you can see on the left hand side, top left hand side, what is the genre types. So it is film reviews, 13.9%. Pop culture is the podcast, and artist NPR is the artist. There are several charts that can be used in KNIME, but I will list a few of them. And other feature that is very good, instead of opening each and every individual chart, there is a visualization layout where we can drag and drop all the visualizations in one single window. And what it does is when we go back to the entire component, we can have a full dashboard view of all the charts in a very single window. Like we have the explanatory data analysis that I showed before, and the sunburst chart, and also a few box plots and the pie charts and bar charts all in one page. And the sky is the limit to build charts and to build all the data visualization. And above all, these are the few charts that are inbuilt in KNIME. And KNIME also has a feature of Python. So if you have a code that you already done it in Jupyter Python, and you have for example, heat map analysis, you can pick up that code and you can plug it in KNIME in the Python script component, and it will create the chart for it. And this is the end of the demo. I would like to go back to the presentation. KNIME offers two editions. One is the analytics platform and a server. Analytics platform is more open source, free to download, and we can use it free. But there's another edition, server edition. I really opt for the server edition. The reason is it has more of collaborative workflow features among the team members that I discussed. So the server creates a very thin, or the gap is so minimized that the entire workflow from raw data source to the productionization is very orchestrated. See, no gaps, and it is also very effective. Another feature of NIME server is when it has been it's been provisioned in AWS, it creates NIME engines where the processes are broken into several other processes, and the processes run more effectively, and the execution time is very less. Um, uh, but since this is for a presentation of Neo4j and NIME Analytics for free, I just took that edition. I used that edition, and there are several references that you can use. NIME is one of the great resource. Homepage is a very great resource to download and learn about NIME. And NIME also has a very good learning paths for various platforms or various streams of roles like data scientists or data analysts. It is really a very easy tool to learn. There's a small learning curvature, but I think with the given fact it's a drag and drop. It's really very easy, and it's very quick, and they have NIME has a lot of resources that you can read the blogs and the news updates, and really it's very self-explanatory. Last but not the least, I know we are all very too busy in analyzing the data, wrangling the data, but there's always a tool there to help us to be more effective and to be more productive, and and NIME is one of them. I hope I covered an overview of NIME along with the Neo4j extension. I'm happy to take any questions. If I'm not able to answer them, I will be more happier to get back if when I get an answer. Thank you.